How to implement coordinate frames in robotics engineering. Imagine trying to tell a robot where to pick up an object or how to move its arm precisely. Without a clear system of reference points, it's like giving directions in a foreign city without a map. That's where coordinate frames come into play. They act as the robot's way of understanding space and position. Think of them as invisible grids that help the robot see where everything is and how it's oriented. The first step is to set up the world coordinate frame. This is like the global map of the robot's environment. Usually, it's fixed to the floor or a wall, and its origin is at a known point. Its axes are aligned with the walls or floor, giving a stable reference point for everything else. Next, you attach the robot coordinate frame to the robot's base. This frame moves with the robot and helps describe the robot's position relative to the world. It's like a personal map for the robot itself. Then, you define tool coordinate frames. These are attached to the end of the robot's arm or tools like a welding torch or gripper. The origin is usually at the tool center point, which is the exact spot used for positioning during tasks. This makes sure the robot knows exactly where its tool is in space. You can also assign object coordinate frames to objects the robot interacts with, like parts or fixtures. This helps the robot understand where things are relative to the world or itself. To connect these frames, you use mathematical transformations. These are like instructions that rotate and move one frame to match another. They are represented by rotation matrices and translation vectors. These transformations let the robot convert positions from one frame to another, like translating a point from the tool's frame to the world frame. It's important to follow the right-hand rule for axes orientation. This rule makes sure the axes are consistent and predictable. Imagine holding your right hand with your thumb, index, and middle finger pointing in the directions of the axes. Most robotics software includes tools or libraries that help manage these coordinate frames. They let you define frames, perform transformations, and keep track of multiple frames easily. This is essential for tasks like motion planning, where the robot calculates how to move from one point to another, or multi-robot systems, where different robots share a common workspace. When changing tools or adding sensors, defining specific frames ensures everything aligns correctly. Sensors like cameras or laser scanners also have their own frames, which are related back to the robot, or world frames for accurate data interpretation. Getting coordinate frames right is fundamental for robot kinematics. It allows the robot to move precisely and interact smoothly with its environment. Setting up the frames carefully, using consistent transformations, and following standard conventions make sure all parts of the system understand spatial relationships clearly. This way, the robot can perform complex tasks reliably and efficiently.